Today we're going to be talking about continuous versus terminating decimals. Think about what continuous means to you. Continuous usually means something that goes on forever or goes on for a really long time. So a continuous decimal is a decimal that goes on forever. And how we annotate that or how we write that is with a line above the numbers like we see here on 1.33. That line above the 3 means that that number, that decimal is going to go on forever. So the 3 is going to keep repeating on forever. But to make our writing a little bit shorter, we put 1.33 with a line above it. So we don't have to write a bunch of 3s. Terminate. Terminate means to end something or that it stops. So 1.75, the number stops. It doesn't go on forever. It's just 1.75. And that's it. Okay? Okay, now we're going to talk about the real number system. We need to label the diagram with the correct name and write the numbers in the correct category. We learned these categories the other day. The smallest category is the natural numbers. So here in the smallest box, I'm going to write natural. Okay, we can cross that out. The next category is whole. The third category is integer. And the biggest category is rational. Okay, now we need to put the numbers in the correct category. So we're going to start over here with -2. -2 is a whole number, but negative. And it's found on the number line. So it's an integer. So we're going to put it in the integer box. 0 is a whole number. Okay, it's not a counting number, but it's a whole number. So we're going to put it in the whole number box. 5.3, that's a decimal, so that's rational. Decimals and fractions always go in the rational box. The number 4, that's a natural number. It's positive, it's whole, and it's a counting number. So I'm going to put 4 in the natural box. 0.33 repeating. It's a decimal, so it's going to fit in the rational box. -2 and 1/4. -2 is an integer, but this is -2 and 1/4. So it turns into a decimal, or even as a fraction, it is a rational number. So we're going to put it in the rational number box. 7, that's a positive whole number, and it's a counting number. We can count to it. It's natural, so it's going to go in the natural box. -22. It's an integer because it's negative and it's whole, so it's going to go in the integer box. It can also be found on the number line. If you can find a number on the number line, it's probably an integer. So -22. So that's where you would place all of those numbers correctly in the diagram. Okay, this Venn diagram shows the relationship of the subsets and the real number system. Which of the following sets would belong to the integers? So we need to see which set would fit in the integer category. Which set of numbers can you find on the number line? Remember, they need to be whole, they need to be positive or negative, they cannot be decimals, and they cannot be fractions. So let's eliminate all the answers that have decimals or fractions. Does F have any decimals or fractions? No. So let's leave it alone. Let's look at G. Does G have any decimals or fractions? Yes, it has decimals, so it's not going to fit in the integer box. So we're going to cancel it out. H. Does H have any decimals or fractions? Yes, it has decimals, so that is not the correct answer either. Let's look at J. Does J have any decimals or fractions? Yes. So again, J is not going to be the correct answer. So our correct answer here is F. 7, -3, and 17 can all be found on a number line. They are all positive or negative whole numbers. Which graphic organizer correctly groups the following numbers? So we need to pick which answer choice has the numbers in the correct spot. Okay, so let's look at the whole numbers. Whole numbers must be counting numbers. So think of 1, 2, 3, 4, 5, 6, 7, and so on. So what answers do not have counting numbers in them? G. G has a -8 in the whole number box. -8 is not a whole number. So we're going to eliminate G. Okay, next, let's look at the integers. Integers are numbers that are found on the number line, positives and negatives, and they're whole. So we need to eliminate the answer choices that do not have positive or negative whole numbers in the integer box. F and H both have decimals in the integer box. So those are not the correct answer. So we're going to eliminate F and H. We look at J and we look at -2.5 and 1.3 repeating. Those are both decimals and they're both in the rational number box. So J is correct. Next, we're going to be talking about variables. A variable is a letter that represents a number. When you look at a variable, you see a letter. It could be any letter of the alphabet. So think about an example of a variable. You could say B, you could say C, you could say Y, Z, S, V, W, any letter of the alphabet could be a variable. So name the variable in this expression, x plus 4. What is the variable? If you said x, you're correct. X is the variable in this expression. Now we're going to learn about substitution. Substitution is replacing a letter with a number. They will tell you what the value of the variable is. You replace that variable with that number and evaluate or get the answer. So we're going to evaluate the expression for x equals 5. My expression is x plus 4. This is telling me that x is equal to 5. So instead of writing x again, I'm going to replace it with 5. So I'm going to write 5 plus 4. 5 plus 4 is 9. So I evaluated, I got the answer. My answer is 9. Let's try another one. Evaluate the expression for x equals 13. We have x plus 7. We know that x is equal to 13, so we're going to rewrite that. 13 plus 7. 13 plus 7 is 20. So we evaluated and our answer is 20. Let's try one that looks a little different. Evaluate the expression for a equals 7. We know that a is equal to 7 and our expression says a minus 1. I'm going to rewrite it and instead of writing a, I'm going to write 7. 7 minus 1. 7 minus 1 is 6. So I evaluated and my answer is 6. Find the product. 2.4 times 2. These parentheses right here means to multiply. Okay, so I'm going to multiply 2.4 and 2. Product also means to multiply. So whenever you see that word, you know that you're going to multiply. We're going to put 2.4 on the top because it has more numbers and 2 on the bottom. Let's multiply. 2 times 4 is 8. 2 times 2 is 4. Now we have a decimal. We need to look and see how many numbers we have behind our decimal. We have one number behind the decimal. One number behind the decimal. So we're going to move our decimal one time in our answer. 1. So our final answer is going to be 4.8. Let's practice working with some integers. This one says to find the sum. Okay? First, what I'm going to do is I'm going to circle my two numbers and whatever sign is in front of them. Okay? I have 3 and -6. Find the sum. 3 minus -6. Whenever you see a double negative or two minus signs next to each other, your first step is to fix it. So what we're going to do is we're going to fix this to a big plus sign. That's what happens when you see two minus signs or two negative signs next to each other. You fix it into a plus sign. Then you solve the problem. We have 3 plus 6 if we rewrite it. And 3 plus 6 is 9. That's our final answer. Benchmark percents. What does each square represent as a fraction? Count the squares. So we know the whole bar equals 100%. We want to know what each individual square represents as a fraction right now. So we need to count the squares. 1, 2, 3, 4, 5, 6, 7, 8. So there's 8 total squares. The 8 is going to go on the bottom because that's our total. And it says, what does each square? So I want to know what one square is out of 8. Okay, so each square, one square out of all of them, which is 8, is our fraction. So 1 out of 8. Each square represents 1 out of 8 total. Let's try this one. What is the fraction of the shaded strip diagram? We need to use the same steps we just used. We first need to count how many squares we have on our strip diagram. 1, 2, 3, 4, 5, 6, 7, 8. That's our total, so remember that goes on the bottom. It's asking about the shaded. How many are shaded? Let's count and figure out how many are shaded. 1, 2, 3. 3 of the boxes or the squares are shaded. So the fraction of this shaded strip diagram is 3 out of 8. That will be our final answer on this question. Let's try this one. What is the fraction of the shaded strip diagram? First, we need to count all of our squares. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Remember, our total goes on the bottom of our fraction. And then we're going to count how many are shaded. 1, 2, 3, 4, 5, 6, 7. 7 out of 10 are shaded. So 7/10 is our final answer for the fraction of our shaded strip diagram. Benchmark percents again. What does each square represent as a fraction? Again, we need to count how many squares we have. 1, 2, 3. Our total goes on the bottom of our fraction. Then we need to count how many we have that are shaded. 1. So that's going to go on the top of our fraction. So our fraction is 1/3.